Good day all, and welcome once again to my YouTube channel. So today we are going to be looking at bases, and in our previous video we considered acids. So I'm done with everything about acids. So now we are going to be looking at bases. Now, looking at the definitions of bases, in the previous video I told you that according to Svante Arrhenius, he defined bases as substances when dissolved in water produces hydroxide ion as the only negative ion, OH minus. So whenever you see this, just know that it indicates base. Then whenever you see H plus, it indicates acid. Alright, that's according to Svante Arrhenius. And then two other scientists, they came together and then they gave their definition of bases to be proton acetals. According to Johannes Bronsted and Thomas Lowry, he said that bases are proton acetals. Then Gilbert Martinelli said that bases are electron pair donors. Alright, so now looking at Svante Arrhenius' definition of bases, he said that if you are having water, let's say you have this beaker containing water H2O, and you dissolve a base, what happens is that it tends to flourish or produce OH minus, indicating the presence of base. There is a reaction that is written as follows. Now, whenever you see a reaction like this, know that this thing represents acid, while this one represents base. So an acid-base reaction is also known as neutralization reaction. A question has been asked on this before. It came out in JAM. And then they were like, the reaction above is an example of what type of reaction? And the answer is neutralization reaction. So let's deal with bases. Now, we have different kinds of bases. I'm going to show you the discrepancy between base and alkali or alkalis. Now, when we consider bases, we are referring to substances that tend to produce OH minus when dissolved in water. Then alkalis are simply soluble basic hydroxides. So what does that mean? It means that if I'm having NaOH, this is an hydroxide, no doubt, and is a base. But then again, it is an alkalis. Then we also have KOH. Now, sodium hydroxide and potassium hydroxide, they are considered to be alkalis. Now, why are they considered to be alkalis? Because they are soluble basic hydroxides, meaning that they dissolve in water and they are bases. Okay, so now it is not all hydroxides that are considered to be alkalis. It is only those that dissolve in water that are considered to be alkalis. Examples include these two. All right, so now you can have this one, copper hydroxide, and you could have aluminium hydroxide. Now look at these two. These two are simply hydroxides. They are bases, no doubt, but then again, they are not alkalis. Why? Because they are insoluble in water. All right, so it is only those soluble hydroxides that are considered as bases, or rather alkalis. And classical examples of them are the caustics. Yeah, they could refer to these two as caustics. Now you could call this caustic soda, and you could call this one caustic potash. All right, so they are the soluble basic hydroxides and they are alkalis. So in simple terms, all bases are all alkalis are bases, but not all bases are alkalis. In simple terms, all alkalis are bases, meaning these two, they are bases, but not all bases are alkalis. In the case of these ones, now these ones are bases, but they are not alkalis. All right, now looking at some of the reactions that bases undergo. Now considering you have, let's say you are given this one. Now we have different types of bases. Looking at the types of bases, remember according to Svante Arrhenius, he said that bases are substances when dissolved in water produces what? Hydroxide ion. Then what pattern with which do they produce the hydroxide ion? Now, I can split them into different types. So I have the type A basis, we have the type B basis, and then we have the type C basis. Now, what are type A bases? All of them, they happen to produce OH minus when dissolved in water. But for type A bases, they are simply bases that produce OH minus from themselves when dissolved in water. Classical examples include the hydroxides. So we have NaOH and then we have KOH. Now, if you dissolve NaOH in water, what happens is this: when it comes in NaOH, it tends to split in water, releasing Na plus and OH minus. So the OH minus that is being produced from this type A bases, they are simply produced from their molecules. Alright? So they are coming from themselves. But looking at the type B bases, they are simply bases that tends to produce OH minus when dissolved in water. And how do they produce the OH minus? They produce the OH minus from water molecule. So what happens is this: when you dissolve a type B base in water, it tends to split water molecule into two parts. Talking about water molecule being split into H plus and OH minus. So when you dissolve a type B base into water, it splits it into H plus and OH minus, and it doesn't stop there. It attacks one part of water, being the H plus, to form a radical, and then you are left with the OH minus. So since it's having the ability to releasing OH minus, then you can also call it a base. Classical example of type B bases includes ammonia. Now, when ammonia is dissolved in water, what happens is this: let's say you have this container containing water and you dissolve ammonia. See the reaction that occurs. First, the water molecule will split into H plus and OH minus. And it doesn't stop there. Remember I said that the type B base has the tendency to attack the H plus while you are left with OH minus. So when this attacks this, it becomes NH3 plus H plus. That gives you NH4 plus. You see it? And then you are now left with what? With OH minus in the medium. Alright? So that's how they produce their OH minus. Then for type C bases, they produce their OH minus by dissolving in water and splitting water without attacking any part of water. Okay? Example includes, we have the Na2CO3. What does this mean? It means that if you dissolve Na2CO3 in water, it tends to split into Na plus and CO3 2 minus, while it also affects water by splitting water into H plus and OH minus. So long the OH minus is being produced, then you can say that this is also a base. All right, so that's for the type C bases. So I've been able to split the bases into different types. So take cognizance of what I've just explained here. All right. Then the next thing that we'll look at would be on the physical properties of bases. Physical properties of bases. Now, when we talk about the physical properties of bases, we are simply referring to features that can be visible to the eyes. So the physical properties of bases. Now, the first is bases. Bases turn red litmus paper blue. Hope you have not forgotten this. You know, in acids, I told you that acids, they turn blue litmus paper red. So it's just like the reverse. For bases now, they will not turn red litmus paper what? Blue. Alright? So don't forget that. Then secondly, concentrated forms of bases are corrosive. Concentrated forms of bases are corrosive. Just like in the case of acids, I once said in my previous video that concentrated forms of acids, they are very deadly and they are corrosive. Same with that of bases. But what kind of bases, whenever they are concentrated, they are very corrosive? They are the caustics. And don't forget, when I say caustics, I'm referring to the KOH and the NaOH. Again, thirdly, now bases are soapy, they are soapy to touch. Bases are soapy to touch. And what does that mean? It means that when you feel bases in between your fingers, they are usually what? Soapy. In fact, interestingly, it is the bases that are commonly used in the manufacturing of soap, that is saponification process under organic chemistry. Alright? Then number 4, bases have bitter taste. Now remember, for acids they have sour taste, but for bases they have what? Bitter taste. And what is responsible for the bitter taste of bases is because of the hydroxide ion that is usually produced by bases that constitutes that bitterness of taste. Okay? Then number 5, bases usually have pH values, pH values greater than 7. Okay, so they usually have pH values greater than 7. Don't forget, acids, they have pH values less than 7. Then while that of neutral point is what? Is 7. All right, so when you are coming down in the pH scale ranging from 0 to 14, now below 7 is what? To acidity. Above 7 is what? Alkalinity or basicity. All right, so these are the physical features of bases. So let's see the chemical properties of bases, or chemical reactions of bases. Now looking at the chemical reactions of bases. Now the first chemical reaction would be neutralization. Neutralization reaction. Neutralization reaction. Of course, we have treated this under acids. Now it's simply a reaction between an acid and a base to form salt and water only. And don't forget, the reaction is usually irreversible, meaning that when you have a reaction between an acid and a base, it only proceeds in one direction, forming salt and water. So it means that salt and water cannot be combined to forming acid and base. So this type of reaction is termed neutralization reaction. All right. And the second reaction, which is of interest, is reaction with ammonium salt. Reaction with ammonium salt. Pay attention to this. When we say ammonium salt, now listen, never should you mistake ammonia for ammonium. Now, ammonia has a formula NH3. Then while ammonium has a formula NH4, but usually with plus, indicating that when ammonia combines with hydrogen ion, it gives what? Ammonium ion. So ammonium is NH4, while ammonia is NH3. And when we talk about ammonium salts, we are simply referring to salt compounds of ammonium, talking about NH4Cl. This is a salt compound of ammonium. This is called ammonium chloride, which is even a solid that sublimes. And then we have NH4NO3, that's ammonium nitrate. And then we will have ammonium bromide and the rest of them. Remember that whenever halogen is in combination with other elements, it has a tendency to form the salt compound of the elements that is in combination with. Okay, remember halogens are what? Salt formers or salt producers. All right, so whenever bases react with ammonium salts, they usually liberate a gas. And what gas is that? That's ammonia gas. Don't forget, remember, acids in one of the chemical reactions I treated in my last video. I told you guys that acids react with triazocarbonates to liberating what? Carbon dioxide gas. But in the case of bases tends to react with ammonium salt, liberating what? Ammonia gas. So let's look at that. Now let's pick a base, sodium hydroxide. Now reacting with an ammonium salt, let's say NH4Cl, ammonium chloride, being an ammonium salt compound. So when you carry out this reaction, you would obtain sodium chloride being a salt, and then water ultimately must be formed with the release of ammonia, NH3. All right. Now let's see whether the reaction is balanced. This is one sodium, one oxygen, then five hydrogen, one nitrogen, one chlorine over there. So now the gas that is being produced here is ammonia gas. All right. A question has been asked before in JAM, and then they brought something like this: KOH plus NH4NO3. Then it brought KNO3 plus H2O plus Y, and then they were asking what is Y. It's obvious that this is a base and this is ammonium nitrate being ammonium salt, and then whenever bases react with ammonium salt, they tend to liberate ammonia gas. Amongst the products here, you don't have any ammonia there. You only have potassium nitrate, you have water, and then you are left with one more. And what's that? Ammonia. So the Y here is what? NH3. That becomes the answer. All right. So that's that about that. About the reactions, chemical reactions of bases. There are no much stuffs about bases though, but you can actually prepare bases too. That's the laboratory preparation of bases. Let's look at that. The laboratory preparation of bases. Now, how can we prepare bases? It's very easy. Now, we can simply dissolve some metals, group 1 metals, in water, and then obtain a base with the liberation of hydrogen. For example, when you dissolve sodium, potassium in cold water, what happens is this. Now, when sodium is dissolved in cold water, it tends to produce sodium hydroxide while liberating hydrogen gas. Now, balancing this reaction, you have one sodium, three hydrogens, two hydrogens, then one oxygen and one oxygen. So if we must balance this, we can actually make this to be 2. If we make here 2, then this is 4 hydrogens, so we'll make here 2. So let's see, this is 2 sodium, and this 4 hydrogens, and then 2 oxygen, so everything is balanced. So we have obtained a base. All right. Then you can also carry it out for potassium as well. You can even do it with calcium, but it's just that calcium reacts with warm water. Okay. Or if at all it wants to react with cold water, it reacts with cold water slowly while liberating hydrogen in bubbles. Then as well, you can also carry out the reaction of oxides of metals. Now, when oxides of metals dissolve in water, they tend to also produce bases. Yes, oxides of metals. For example, calcium oxide, we have sodium oxide, we have potassium oxide. Now, when these oxides are dissolved in water, for this one, when you dissolve in water, it simply gives you calcium hydroxide. And of course, if you confirm everything is balanced, this is 1 Ca, 2 oxygen, 2 hydrogen. Then when you dissolve this again in water, it gives you NaOH. Then balancing the whole stuff, you simply just put 2 there because you have 2 sodiums, 2 oxygen, and 2 hydrogens. The same thing is also applicable here. And when you dissolve it in water, it tends to give you 2 KOH. So that's how you can also get a base. By simply dissolving metallic oxides in water, you can obtain a base, and also by dissolving just metals, most especially the group 1 and group 2 metals in water. All right. So those are ways that you can actually obtain bases. Then some of the uses of bases includes the fact that majority of them are used in the making of soap. Now look at these caustics, NaOH and KOH. Now both of them can be used in the making of soap. This one can be used in the making of solid soap. Then while this one can be used in the making of liquid soap. All right. Now this also has other uses. It can be used in the making of glass. Yes, as well as paper. Yeah, you can use it in the making of glass. You can use it in the making of paper. It can also be used in the making of soap. Then in the case of this one has much industrial applications as well. Even this one, magnesium hydroxide. This one can be used in the making of toothpaste. Okay, then even aluminum hydroxide can be used as a mordant in dyeing industries rather. Okay, for dyeing. All right, so we still have quite a number of uses of bases, but they don't usually stress you on uses of bases. Just know the fundamentals of bases, the definitions, the physical properties, the chemical properties, as well as the preparation mechanism. I've been able to explain all that. So it's my hope that you've been able to understand what I've just explained concerning bases. The next video will be looking at salt. So don't forget to subscribe to this channel, share the videos if you like, place your thumbs up there, and then stay tuned to the channel as more videos are coming on the way. Thanks for watching and God bless.